I'm going to explain some of the answers to the electron configurations basic practice. One of the things that you're asked to do is to explain what each portion of electron configuration notation represents. The first thing that we're going to look at is this number 1. Remember that that large number 1, the first number that's written, represents the energy level of the element. Of the electron's location. Remember, energy level is defined as the distance of the electrons from the nucleus. So the further the electrons are from the nucleus, the higher the energy level. The next thing that we're going to see is this lowercase letter. That lowercase letter represents the sublevel of the electron's location. Remember, sublevel represents an area of probability of the electron's location. That area of probability can be a different shape, whether it depends on it's an S, P, D, or F. Don't forget that the superscript represents a quantity in that particular position. So let's take a look at some of these elements. The first element that you're asked to describe the electron configuration of is helium. So what we're going to do is we're going to look at helium on the periodic table. Helium is located in the first row. So the first thing we're going to do is look at its row number, which is 1. And we're going to see that we're going to count over the number of squares to get to helium. 1, 2. And it's in the S sublevel. So we're going to write down that helium's electron configuration is 1s, and then the superscript tool is up here, 2. That did not work. Let me try again. 1s2. So that takes into account that helium has 2 electrons. The second element that we're going to take a look at is lithium. So let's go find lithium on the periodic table, and we'll notice that lithium has 3 electrons, but we can't start with the second row. So here's the second row. I'm going to rewrite this number 1. We're going to have to start in the first row, because remember, the first place we start is always in this top corner. So we're going to have to write the first row's electron configuration, which is 1s2. Then we'll start with the second row, which is 2. We're in the S sublevel, and how many squares do we count over to get to lithium? 1. Now, whatever our superscripts are, they're going to definitely need to add up to 3. So let's go back to our examples. We're going to write 1s2, and then we're going to write 2s, and then the number of squares we counted over was 1. All right, let's try another one. The next one is nitrogen. So let's find nitrogen on our periodic table. All right, here's nitrogen. It's in the second row in the P sublevel, but we're not going to be able to start in the second row in the P sublevel. Remember, we have to start with its inner electrons and then work our way to its outer electrons. So we're going to start with 1s, 1, 2, 2s, 1, 2. Now we can start in with the 2 p's. So now that we're starting in with the 2 p's, we'll count over the number of squares it takes to get to nitrogen. 1, 2, 3. So let's go back up to our example, and we're going to type in 1s2, and then we're going to type in 2s2, and then we'll type in 2p, and we had to count over 3 squares to get to nitrogen. All right, let's go ahead and take a look at a different element in our section. Let's go ahead and do scandium. All right, scandium is one of those electrons that's in the D sublevel. It's all the way down here. So remember, the D electrons are a little bit different. When you do the D electrons, we're going to have to start at the top, but as you get closer to the D sublevel, the energy level changes, and we can remember why from our video. So for scandium, we're going to start out with 1s2, 2s2, 2p, and we count over 1, 2, 3, 4, 5, 6. We got to keep going to the third row, so we're going to do 3s2, then we hit the 3p, 1, 2, 3, 4, 5, 6. We're still not to scandium yet, so we're going to start with a 4s, so this is the fourth row, 4s, 1, 2. Now remember, even though you're theoretically in the fourth row, the energy level changes when you get to the d electrons, because the 3d sublevel is higher in energy And then the 4s, and as we do electron configuration, we always go from lowest energy to highest energy. So what we're going to need to do is go, after the 4s2, we're going to go 3d, 1, 2, 3, 4. Sorry, I got too excited. We're doing scandium. So, sorry, for 3d, we're going to count over 1. So let's go back up to our problem, and we're going to type in 1s, then come up to the superscript tool, 2. 2s, superscript tool, 2. Sorry, 2p, 6. 3s, 2, 3p, 6, 4s, 2, and then we're going to go down to 3d, and we counted over 1 space to get to scandium. All right, last but not least, this section asks us to write the abbreviated or noble gas electron configuration. So recall that that's the way that you can shorten electron configurations, by using the noble gases to shorten the electron configuration. So let's start with something easy. We're going to do phosphorus. All right, so phosphorus is located here in the 3rd row, or 3rd energy level. So we need to find the noble gas that ends the row before phosphorus. Remember that this last column here are the noble gases. So here's phosphorus in the 3rd row. The noble gas that ends the row before phosphorus, so we need to find the one that ends the 2nd row, is going to be neon. So now we're going to count and find out what's after neon's electrons until we get to phosphorus. So after neon, we have 3s2, 3p1, 2, 3. So let's go and type that into our answer. So we're going to need to use square brackets for neon. And then after neon, we had 3s2, 3p, and we counted over 3 squares to get to phosphorus. Let's try an element that's in our D sublevel. So let's go ahead and try silver. All right, so for silver, a lot of people get its symbol confused. Its symbol is Ag. It's all the way down here. It is in this 5th row, so we're going to need to find the noble gas that ended the row before it. So what noble gas ended the row before the 5th row, which would be the 4th row? It's going to be krypton. So krypton ended the row before it. So we're going to put krypton in square brackets. And after krypton, we have 5s, 2, then we're going to go 4d, and we need to count over the number of squares so we get to silver. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's go ahead and write that down as our answer. So recall that we had, for our noble gas that ended the row before silver, we had krypton. Close the square bracket, and we're going to have 5s, 2, and then we had 4d, and we counted over 9 spaces to get there.